Jai Shri friends, Gravitation lecture number 46. Today's topics are vector form of law of gravitation, superposition law, and then Newton's Shell theorem. Let us start. Now, first of all, we shall discuss about vector form of the law of gravitation. As you can see in this diagram, there are two masses m1 and m2 at a distance r. So there are forces f12, f21. Similarly, unit vectors r12 and r21. So see what's the meaning of different words for different terms like this. So f12 is equal to minus of g m1 m2 upon r square in the direction r21. So this is unit vector showing the direction. So negative sign shows the direction of f12 is opposite to r21. Fine. Similarly, we can say f21 is equal to minus of g m1 m2 upon r square in the direction of r1. So this is one thing. Now the notations, as I'm saying that r1 to cap means the unit vector from 1 to 2. Similarly, r21, and you can say f12 is nothing but force on 1 due to 2. Similarly, f21 can be defined. Okay. Now, in more general form, we can see that you can see this diagram in which the two masses m1, m2 are having position vector r1, r2 like this. So the position vector from m1 to m2 is nothing but r2 to r1. So implying this, we can say f12 is nothing but g m1 m2 upon mod of r2 minus r12 in the direction r2 minus r. And similarly, f21 is equal to minus of g m1 m2 upon r2 minus r1. Q means the negative sign of this. So same expression with negative sign. Okay. So this is more general form. f12 is equal to minus of f21. I hope you get it. Now, next one is what is the implication of vector form of the law of gravitation. So let us see. This diagram shows, as I've already discussed, f12 is equal to this expression. Similarly, f21 is equal to this expression, as you can see here. Okay. Now, what is the implication? First point is, as r21 cap is equal to minus r12 means unit vectors are just opposite. Therefore, the two forces are equal and opposite to each other. So you can say two particles form action reaction pair. Second implication is, as f1, f2 and f21 are directed towards the centers of the two particles, so gravitational force is a central force. Now, important features of gravitational force. Number one, the gravitational force between two masses is independent of intervening medium. Second point is, the mutual gravitational forces between two bodies are equal and opposite. That is, they form the action and reaction pair. Hence, gravitational forces obey Newton's third law of motion. Third point is, the law of gravitation strictly holds for point masses. Now, further, the gravitational force between two point masses is the central force. Its magnitude depends only on r and has no angular dependence. Thus, the gravitational force possesses spherical symmetry. Similarly, next point is, the gravitational force is a conservative force. Okay. And finally, we can say the gravitational force between the two bodies is independent of the presence of other bodies. Now, what is the principle of superposition of gravitational forces? You can see in this diagram, there are different masses are having different distances with respect to each other. So there is a diagram which shows the illustration of principle of superposition of gravitational forces. So what we can say, according to principle of superposition, number one, the gravitational force between two masses acts independently and uninfluenced by the presence of other masses. Second point, the resultant gravitational force on a body will be the vector sum of all the gravitational forces acting on that body. Fine. So in expression form or in mathematical form, you can say F1. For example, the total force working on mass M1, say this, is given by F12 vector plus F13 vector plus F14 vector as per the this diagram. So summation form, this is I21 1 to n Fi vector. Similarly, we can calculate the forces for other masses also. Now, next topic is Newton's Shell Theorem. So there are two different cases. One is outside and another is inside. So first, let us discuss about outside. So in this diagram, you can say there are two diagrams. One is for shell, okay, and another is solid sphere. Now, a particle is lying outside means the distance of particle is just away from, means r is greater than equal to r, means r is the radius of this shell or the solid sphere. So you can say from this, if a point mass lies outside a uniform spherical shell or sphere with a spherically symmetrical internal mass distribution, the shell or sphere attracts the point mass as if the entire mass of the shell or sphere were concentrated at its center. So this is the main logic. Accordingly, we can find out the expression. As you can see in this diagram, F is equal to G capital M into small m upon r square, where r is greater than equal to r. Similarly, in case of the solid sphere, also the same expression holds. Okay, so I think you can understand this. Next is Newton's Shell Theorem for inside or the shell sphere. So now this is the case where small r is less than equal to r. Okay, so this less than r. So F is equal to 0. So in this case, basically what is happening? If a point mass lies inside a uniform spherical shell, the gravitational force on the point mass is 0. So this point should be remembered. Okay. Next is, but if a point mass lies inside a homogeneous solid sphere, the force on the point mass acts towards the center of the sphere. This force is exerted by the spherical mass situated interior to the point mass. Okay. Now, gravitational shielding. What is gravitational shielding? As we can know, see this. Although the gravitational force on the particle inside the spherical shell is 0, as we have just discussed, yet the shell does not shield the other bodies outside it from the exerting gravitational forces on the particle lying inside it. As you can see in this diagram, so what we can say, the gravitational shielding is not possible, but electrostatic shielding is possible. Now, further, there are certain important points which are to be kept in mind for gravitational law. Number one, is this. See, the law of gravitation is strictly true for point masses. However, it is valid in the following circumstances also. Number one, the two bodies of any size, provided the both have spherical symmetry, as you can see in this diagram. Similarly, second point is when one body has spherical symmetry and the other is small compared with the separation between the center, as you can see in this diagram. Okay. Third point, important point, when neither body has spherical symmetry but both are small compared with the separation between their centers, as you can see in this diagram. So in this case, this is valid in these circumstances also. Next is the value of G does not depend on the nature and size of the masses. Second point, the law of gravitation is universally valid. Mind you, it applies to small bodies on the Earth, planets in the solar system, and two galaxies. Okay. Third is very, very important point. Though the gravitational force between the two particles is central, the force between two finite rigid bodies is not necessarily along the line joining. This should be kept in mind. They are the center of the mass. For a particle lying outside a spherical symmetrical body, the force acts as if the mass is concentrated at the center of the body. Therefore, this force is central. जैसा मैंने आपको बताया, ठीक है? डिस्कशन की हमने जो आउटसाइड द शेल में जो डिस्कस किया ना, वही पॉइंट है यहाँ पर. तो ये एक इंपॉर्टेंट पॉइंट है. फोर्थ पॉइंट इज द ग्रेविटेशनल फोर्स ऑन अ पार्टिकल lying inside a hollow body of any arbitrary shape is. Okay. Now, see one numerical question. Calculate the force of attraction between the two balls, each of mass 1 kg, when their centers are 10 cm apart. तो इसमें सिंपल है. ये एक्सप्रेशन आप देखिए. What is the expression? See, this is the formula. Okay, all the values are given. You just place the values and get the answer like this. So the F is equal to 6.67 into 10 to the power minus 9 Newton. This is the answer. Okay. Next numerical problem is two particles each of mass m go around a circle of radius r under the action of their mutual gravitational attraction. Find the speed of each particle. See, this is the diagram for the question. Okay. The force on each particle is directed along the radius of the circle, isn't it? So the two particles always lie at the end of a diameter so that the distance between them is 2r always. So ये diagonally ये जो distance होगा 2r होगा because radius given is r. Now see the formula. F is equal to g m into m upon 2r square because mass is r of same magnitude. So this is equal to g into m square upon 4r square. Now this would be basically balanced by centripetal force. So what is centripetal force? M into v square upon r. Both आप दोनों को equate कर दीजिए. So you are getting v velocity is equal to under root g m upon 4r. So this is the answer for the problem. So I hope you got this. So this is all for today's lecture. We shall see you in the next lecture. Till then, Jai Shri Ram.